Good morning, everyone. So I will be talking about embodied carbon in the streetscape, which considers if we need to factor in the elements that form the streetscape before thinking about surface level carbon emissions. This thought piece is a starting point to demonstrate how the embodied or capital carbon emissions can be derived for individual elements of the streetscape to illustrate how carbon savings can be made at this level. These values have been applied to a virtual typical existing street as well as a virtual future street, both 1 kilometre in length, and the full reports will be made available on the MORE website. So the units I refer to briefly are carbon dioxide equivalents, embodied or capital carbon, and operational carbon. Next slide, please. So the typical street is defined here as a streetscape comprising elements usually found on the majority of urban streets today. This is deliberately conservative at the moment so as to more clearly understand the overall change in carbon use from the situation now and in the future. Next slide, please. The individual components of the streetscape are identified here, and I'll discuss just a few of these now with regards to their capital carbon impacts. Next slide. Looking first at road surface and considering asphalt, which is the most popular surfacing material in the UK, the capital carbon is formed of 44% aggregate and binder and 56% through the heating and mixing processes. Total, it's estimated that a tonne of new asphalt emits approximately 50 kilograms of carbon dioxide equivalents. And applying this to the typical street results in about 16.5 tonnes of carbon dioxide equivalents. Next slide. So internal combustion engine or petrol and diesel cars are considered here to make up all of the fleet on the typical street. The capital carbon values of a car include the materials, manufacture, and transport costs. As the size and power of cars varies widely, so do the embodied carbon values. Taking a medium-sized car, for example, is calculated to generate about 5.6 tonnes of carbon dioxide equivalents before it drives its first mile. For the typical street, the maximum capacity of an urban road has been used to understand how many cars could use this link in an hour. Using this figure, the capital carbon impact of petrol and diesel cars on the typical street is 8,400 tonnes of carbon dioxide equivalents in an hour. However, over its operational lifetime, this medium-sized car is estimated to generate a further 27 tonnes of CO2e. Next slide. So the carbon footprint of a cycle hire scheme on the streetscape relates to the materials, production, maintenance, and rebalancing of bikes. The capital carbon value of a single bike is reported to be around 65 kilograms of CO2e. Assuming 10 bikes stopped on the typical street, this is 650 kilograms of CO2e. The operational footprint of a push bike is almost neutral, but fuel for the rider and heat produced is a consideration. The total operational carbon footprint is therefore estimated to be approximately 2 tonnes of CO2e over 5 years. Next slide. So LED bulbs, looking at street lighting, are already replacing incandescent bulbs in many places, with 55% of all bulbs now used in the UK being LED. The capital carbon impact of an LED bulb is on average 5.3 kilograms of CO2e. However, this does not include the lighting column or other elements such as maintenance. Based on 30-metre spacing, the impact on the typical street is therefore 175 kilograms of CO2e. Next slide, please. So here is a summary of the indicative values derived for each streetscape element where data was available, as well as an indication of the levels of operational carbon over a 10-year period. This demonstrates a total capital carbon value in the order of 8,700 tonnes when looking at the typical street as a whole, and about 3.5 billion tonnes of carbon over a 10-year operational period. So moving on with the next slide to the future street. This is a streetscape that improves upon the typical street using interventions that are either available and happening now or rapidly gaining traction. So it's very much a realistic scenario. Next slide, please. All of the typical street elements are retained and new street components have been added, including electric vehicle charging points, trees, and drones. And I'll just discuss just a few of these now. Next slide, please. So looking again at asphalt for road surface, the material itself is fully recyclable, which can cut 44% of carbon emissions overlaying a new road using new materials. This means the embodied carbon value is around 28 kilograms of carbon dioxide equivalents per tonne of recycled asphalt. For the future streets, this is approximately 9 tonnes of CO2e. Extending the lifespan of asphalt can cut this further. For example, extending the lifetime from 20 to 40 years then recycling it reduces the carbon footprint from around 2.5 kilograms of CO2e per tonne of asphalt per year to just 700 grams. Next slide, please. So electric cars are considered here for the future streets. Due to the high concentration of embodied carbon for the car battery, electric cars generally have a higher impact on capital carbon than petrol diesel cars. This means that the capital carbon is around 8.8 tonnes of CO2e for a medium-sized car. For the future street, this is in the order of 13,200 tonnes of CO2e in an hour. Whilst capital carbon costs tend to be higher, the operational emissions are far lower, where 28,000 kilometres is the average break-even point when an electric vehicle starts to have a positive impact over a petrol vehicle car. So the operational carbon footprint relies on how the electricity is produced. And at the moment, it is estimated that in 95% of the world, it is cleanest to drive an electric vehicle. And it's expected that electricity production is moving towards climate neutrality. Next slide, please. Looking at bus stops, improving the materials can result in a negative carbon impact of around 166 kilograms of carbon dioxide per stop. And there are possibly more savings to be had, such as greening roofs. Assuming a stop every 400 metres for the future street results in a capital carbon impact of negative 664 kilograms of CO2e. Next slide, please. So looking now at electric vehicle charging points. This is a new component for the future street and will add to the overall capital carbon in its materials, production and electrical supply. However, the benefit of facilitating the use of electric vehicles is clear. The footprint of the electricity supply determines the operational impact, and as with other elements requiring electrical power, this is moving towards carbon neutrality. However, at the moment, it's estimated to equate to approximately 40 grams of CO2 per kilometre driven by an electric vehicle. Next slide, please. So street furniture varies, but taking a simple bench as an example, using wooden benches has an enormous benefit to the overall capital carbon on the future street. It's estimated that the impact is negative 113.5 kilograms of carbon dioxide per bench, which for the future street is about negative 1.33 tonnes of carbon. Next slide, please. So underground utilities, the material choice is fairly restricted by the functional technical capabilities of each service. However, there are improvements to be had. For example, broadband is already moving from copper to fibre optic in many places. This allows for a reduction of exchanges and less heat being produced, meaning less cooling is needed and thus less energy is spent. An extraction of 2 kilograms of copper needed for a 200-foot length of wire produces approximately 1 tonne of CO2e. Production of the equivalent length of fibre optic cable produces only 60 grams of CO2e. Next slide, please. So many streets already have grass verges and trees, although it's thought more can be done to create carbon sinks in the streetscape. Trees sequester a meaningful amount of carbon once fully grown and over their lifetime. Therefore, they must be allowed to reach maturity and remain in place for decades to aid in reducing carbon in the streetscape. A typical tree absorbs approximately 1 tonne of CO2 over a 100-year lifetime. Assuming trees remain in place for their lifetime, for the future street, this is around negative 400 tonnes of capital carbon. Next slide, please. Ground and air drones are a relatively new innovation, which are rapidly gaining popularity for deliveries, in particular, replacing car and van trips. Whilst there is little information on the embodied carbon available right now, an air drone is at least 26 times more efficient than the alternative mode of transport, as illustrated here. And then next slide, please. Here is a summary of the indicative values derived for each streetscape element where data was available. This demonstrates for the future streets a capital carbon value in the order of 13,000 tonnes when looking at the streets as a whole, with a generally neutral operational impact over a future 10-year period. Next slide, please. So the purpose of this thought piece is to compare the capital carbon impacts between the typical and future streets to demonstrate how savings could be made before surface level emissions are accounted for. This study has illustrated that, considering these values as a starting point, the overall capital carbon impact of the future street is likely to be higher than the typical streets. This is vastly due to the increased embodied carbon footprint of electric vehicles, which form a large part of the streetscape. However, in considering a simplistic total of the operational emissions, it is clear that there are large savings to be made with this approach through the facilitation of electric vehicles and bikes in combination with those other streetscape elements. Next slide, please. So building on this study might include deriving further information on the capital carbon costs of the missing streetscape elements, such as EV charging points, drones and utilities, as well as for buses and an underground service. It'd be useful to expand the streetscape to look at the entire ecosystem, including street-side buildings, as well as the impact on working from home on carbon in the streetscape, offset against higher energy spending within the home or third place. And final slide, please. Thank you all for your attention.